Okay, so just in the previous lecture, that summary of your per unit equations, that base quantities, that all summaries, just repeating once again. There is a stator base quantities, that is 3-phase volt ampere base is equal to volt ampere rating of machine, that is in volt ampere. Then ES base, peak value to neutral voltage in terms of volt, and rated frequency, that is F base, right? And this is IS base, peak line current, that is in ampere, 3-phase volt ampere base divided by 3/2 ES base. Then ZS base is equal to ES base upon IS base, this is ohm, and omega base is equal to 2 pi F base, that is electrical radian per second. All these things we have seen, it is just a summary, right? Then your omega base, it is this one, and omega mechanical base, so omega base into 2 upon Pf, that is mechanical radian per second. Then Ls base is equal to Zs base upon omega base, this is Henry, and psi s base, the flux linkage one, that is Ls base into Is base, that is Weber turns, right? And rotor base quantities, this all we have seen before, right? These are all summaries. And your IFD base is equal to LAD upon LAD into Is base, this is ampere. IKD base is equal to LAD upon LAKD Is base, this is in ampere. IKQ base is equal to LAQ upon LAKQ Is base, this is in ampere, right? And EFD base is equal to 3-phase volt ampere base upon IFD base, this is in volt. Then ZFD base, EFD base upon IFD base, this is in ohm, is equal to 3-phase volt ampere base by your divided by I square FD base. This one numerator and denominator one can multiply by IFD, right? And ZKD base is equal to 3-phase volt ampere base upon I square KD base, that is ohm, and ZKQ base 3-phase volt ampere base upon I square KQ base, this is ohm, right? And LFD base is equal to ZFD base upon omega base, this is Henry, and LKD base is equal to ZKD base upon omega base, this is Henry. Then LKQ base, ZKQ base upon omega base, this is Henry. All these things little bit you try to what to do when, because previously everything has been derived, just try to, I mean, whenever you make it, just try to recall all these things. So no question of recalling also, just if you have understood little bit, you can do easily. And time base is equal to 1 upon omega base second, right? And this is your torque base, 3-phase volt ampere base upon omega base, is Newton meter, right? And complete set of equations in per unit. In view of the LAD base per unit system chosen in per unit, so these are not, we are not putting bar again, right? So but these are all in per unit. So when we are initially when I started, there was no upper bar, and when per unit thing, all the quantities are converted to per unit, at that time we put bar, but after that we are not using bar, but these are all per unit only, right? So LAFD is equal to LFDA is equal to LAKD is equal to LKDA is equal to LAD, very easy to remember, all are same in per unit. Similarly LAKQ is equal to LKQA is equal to LAQ, right? And similarly LFKD is equal to LKDF, right? So in the following equations, two Q axis amorphous circuits are considered. Suppose you have considered K is equal to 1 and K is equal to 2, and the subscript 1Q and 2Q are used, right, in place of KQ to identify them, right, just for the sake of our analysis, right. Only one D axis amorphous circuit is considered, in that case K is equal to 1, right, and it is identified by the subscript 1D because it is KD, so K is equal to 1. Similarly, here it was your this thing 2 KQ, so K is equal to 1, so 1Q and K is equal to 2, so 2Q, right. So 2 amorphous considered on the Q axis, right. So per unit stator voltage equations. Now here we are not putting bar, but these are all per unit, right. Again and again we will not put bar, but this is understandable. But one thing is there, that whatever here equation is written here, right, this you should not see this, you will see this one only. This is due to something I wrote, but only you will see this equation, right. So just hold on. So this is your what you call per unit stator voltage equation. ED is equal to P psi D minus psi Q omega R minus RAID. This is equation 118. EQ is equal to P psi Q plus psi D omega R minus RAIQ. This is 119. And E0 is equal to P psi 0 minus RAI0. This is 120. This one you should not see, the right hand side. So similarly, per unit rotor voltage equation. So in this case, your EFD, this one you should not see. This one you should not see. So EFD is equal to P psi FD plus RFD IFD. then 0 is equal to, because it is a closed winding, other amorphous are, so p psi 1d plus r1d I1d, and we have choose two amorphous on the q axis. Therefore, p psi 1q plus r1q I1q is equal to 0, that is equation 123, and another one is p psi 2q plus r2q I2q is equal to 0, because we have chosen two amorphous winding on the q axis. That is why these two equations are, that is why this, and on the d axis only one, that is why this is one equation, right. So, this is equation 24. This side you should not see. In the subsequent pages also this will come, but you skip that one, only you see this equation number, you will follow this equation number, right. So, now per unit stator flux linkage equation, this already have been derived, right, but this is your what you call, this is just your just summary. So, psi d is equal to minus in bracket LAD plus LL into ID plus LAD IFD plus LAD I1D. This is equation 125. So, this should not be seen. Similarly, psi q is equal to minus in bracket LAQ plus LL IQ plus LAQ I1Q plus LAQ I2Q, because these two terms are coming, because in the q axis we have chosen two amorphous winding. This is equation 126, and psi 0 is equal to minus L0 I0. This is equation 127. This you should not see, this equation number, right. So, similarly, per unit flux linkage equation. So, in this case, this one also you should not see, only you will see this equation number, So, psi FD is equal to L FFD IFD plus L F1D I1D minus LAD ID. This is summary only, but everything is in per unit, but bar has been removed, right. And psi 1D is equal to L F1D IFD plus L 11D I1D minus LAD ID, right. Similarly, psi 1q is equal to L 11q I1q plus LAQ I2q minus LAQ IQ, right. Similarly, psi 2q is equal to LAQ I1q plus L 22q your I2q and minus LAQ IQ, right. So, this way your what you call, this is the per unit flux, your rotor flux linkage equation, right. So, then per unit air gap torque, this we know that T is equal to psi d IQ minus psi q ID. So, this equation number you should not see, this is equation 132, right. So, in writing equation 130 and 131, right, these two, we have assumed that the per unit mutual inductance, that is L12Q, is equal to LAQ, right. This implies that the stator and rotor circuits in the q axis all link a single mutual flux represented by LAQ, right. Therefore, so, and this is acceptable because the rotor circuit represents the overall rotor body effects, and actual windings with physically measurable voltage and currents do not exist. So, next is for power system stability analysis, the machine equations are normally solved with all quantities expressed in per unit, with the exception of time. Everything whenever we time domain simulation we do, later we will see something, right. So, time will be in second, but all other quantities will be in per unit. That actually makes our analysis easier. And usually time t is expressed in second, in which case the per unit your p in equation, your this thing 180 to 124 is replaced by your 1 upon omega base p into p. P we have seen that it is basically ddt by dt, differential operator, right. And similarly, per unit reactance we have seen, but it is a summary. So, just repetition once again, that if the frequency of the stator quantities is equal to the base frequency, the per unit reactance of a winding is numerically equal to the per unit inductance. For example, xd is equal to, we know generally in general x is equal to L omega. So, xd is equal to 2 pi f into LD ohm dividing by Z base is equal to 2 pi f base Ls base on both sides, right. So, xd upon Zs base is equal to 2 pi f upon 2 pi f base into LD upon Ls base, but f is equal to, if it is f is equal to f base, right, then basically xd per unit will be equal to LD per unit. So, per unit of xd and LD are equal because if f is equal to f base, right, generally it is true. So, in that case xd per unit is equal to LD per unit. Therefore, suppose in numerical if it is given the per unit your inductance, right, is given this, that is nothing but per unit reactance too also, right. So that's why this XD/PU, that means this one, that XD per unit, right, is equal to LD per unit, right, and here F is equal to F base. You put F is equal to F base, so this term will be unity, so it will be XD per unit is equal to LD per unit, right. So that is, suppose if it is given inductance in per unit and you require reactance per unit for the numericals, then in that case inductance per unit means is per unit reactance, right. So next is this is steady state analysis, but before that we will take one small example. Just hold on. So this is your what you call this is your example 1. So a 555 MVA 24 kV 0.9 power factor 60 Hz 3 phase 2 pole synchronous generator has the following inductances and resistances associated with the stator and field windings, right. It is given small LAA is equal to 3.2758 plus 0.0458 cosine 2 theta, this is bracket close, this is millihenry. Similarly, LAB is given that minus 1.6379 minus 0.0458 cosine 2 theta plus pi by 3 millihenry, this is given. LFD is given 40 cos theta millihenry, LFFD is given 576.92 millihenry, RA is given 0.0031 ohm, RFD is given 0.0715 ohm, right. So what you have to determine? You have to determine LD and LQ in henries. B, if the stator leakage inductance LL is 0.4129 millihenry, you have to determine LAD and LAQ in henries, right. So this is the problem. So generator is 555 MVA 24 kV 0.9 power factor 60 Hz 3 phase 2 pole synchronous generator, and these parameters, all these things are given, right. So in this case you have to determine LD and LQ at the same time, that if LL is given you have to determine LAD and LAQ in henries, right. Now and C is using the machine rated values as the base values for the stator quantities, determine the per unit values of the following in the LAD base reciprocal per unit system. Then LL, LAD, LAQ, LD, LQ, LFD, LFFD, LFD, RA and RFD, all these things we have to find out in per unit, right. So this is the problem. Now solution from equation, here number I forgot to write, but I am writing it. From equation, this will be equation 60 and this will be equation 61, right. So this is equation 60 and this is equation 61, right. So LD is equal to LAA0 plus LAB0 plus 3 by 2 LAA2, right. So this is actually coming from equation 60. Please go refer to 60, you will get this, right. So this is equation 60 and this is equation 61. So let me clear it. So this blank is given, this 60 and 61. So that means LD is equal to LAA0 plus LAB0 plus 3 by 2 LAA2, right. Now from this data, from this data only, just go back to that equation 60 and see all the quantities there. So what you will get, that this one LAA0 3.2758, then LAB0 1.6379, and then 3 by 2, then LAA2 0.0458. So just directly you substitute. If you do so, you will get LD is equal to 4.9825 millihenry, right. So I mean, if you come to that, here your what you call LA0, then your LAB, this thing is given, AB0, all these things are given. So from that directly you can substitute, right. So that's why we are making it that your this LAB0 then plus 3 by 2 into 0.0458, right. So all these parameters are given from this equation. So, you will get LD is equal to 4.9825 millihenry, right. Similarly, LQ is equal to LA0, this is from equation 61. So, LA0 plus LAB0 minus 3 by 2 LA2, because this already we have derived, right, this is from equation 61. Now, substitute these values. So, 3.2758 plus 1.6379 minus 3 by 2 into 0.0458, that is LQ is equal to 4.8451 millihenry, right. So, this is LQ. Now, part B. Part B, it has been asked that find out your LAD and your LAQ. LAD is actually equal to LD minus LL. This already we have seen. Therefore, LAD is equal to 4.9825 minus 0.4129. So, LAD is equal to 4.5696 millihenry, right. Similarly, LAQ is equal to LQ minus LLL. So, LAQ is equal to LQ is 4.845 minus this LL 0.4129. So, this is LAQ is equal to 4.432 millihenry, right. Straightforward, only you have to put those data in the formula, right. Now, the base values of stator and rotor quantities are as follows. Actually, it is 3 phase, it is given 3 phase volt ampere base, we can take 555 MVA, right. Now, ES base, that is the RMS value, that is your machine base voltage we have to take. So, RMS value 24 kV it is given. So, 24 by root 3. So, it will be 13.856 kV, right. Now, ES base, that is your peak one, right, small ES base peak one, all this terminology has been defined before. It will be root 2 into 13.856, right. So, that is your 19.596 kV, right. So, this is your ES base, small ES base peak. Now, IS base RMS will be, this is MVA base 555 into 10 to the power 6. So, volt ampere divided by your, this is your 3 into 13.856 into 10 to the power 3, because there is 3 phase MVA. So, that is why multiplied this one by 3, right. So, 3 into 13.856 into 10 to the power 3. So, that is coming around 13,351.2 amps, right. Similarly, IS base peak will be equal to root 2 into this value 13,351.2. So, it is 18,881.5 ampere, right, that is IS base peak. Now, therefore, ZS base will be, if you look into that, the ZS base will be your, this thing we got your 13.856 into 10 to the power 3 divided by your 13,351.2, right. So, this is 13,000 your 351.2 and this ES base is 13.856, right. So, 13.856 in 10 to the power 3 upon 13,351.2, it comes around your this is actually one dimension error is there. So, this is actually ZS base, it is actually ohm, right. By mistake I put it ampere, it is ohm, right, because this is ZS base, right. So, this is your ohm. Now, omega base is equal to 2 pi into your F base, that is there, this is your 60 hertz, right. So, that is 377 electrical radian per second, right. So, this is ohm. So, therefore, IS base is equal to your then 1.03784 divided by 37, right. So, sorry, LS, this is LS base, not IS base, LS base, right, because Z is equal to L, general in dimension, ohm is equal to L into omega. So, this is LS base. So, let me make it, this is actually LS base, right, this is LS base is equal to what ZS base, that is 1.03784 divided by frequency base 377. So, 2.753 millihenry. Now, from this formula we know, now let me clear it. So, IFD base is equal to LAD upon LFD into IS base. So, LAD is equal to 4.5696 divided by your 40 into 18,881.5, right. So, that is your 2158 ampere, right. Similarly, EFD base, this is your base MVA, your what you call 555 into 10 to the power 6 volt ampere, and divided by this IFD base. Here it is 2158. This is actually 257.183 kilovolt, that is EFD base. Now ZFD base will be, now EFD base upon IFD base. So this is your, so EFD base is this one, this is your 257.183 kV, and IFD base is 2158.0, this is your IFD base, right, is equal to 119.18 ohm, right. So that is 119.18 your ohm, right. So this is ZFD base. So then LFD base will be now simple, ZFD base upon omega. So it is 119.18 upon 377 is equal to 316.12 millihenry, right. Now all these base quantities now we have determined. Just you have to follow step by step that how to determine all these things. Now the per unit values are, therefore LL will be equal to 0.4129 divided by 2.753, because your here it is LS base is equal to 2.753 millihenry. So therefore your it will be 0.4129 divided by 2.753, so 0.15 per unit, right. Similarly LAD will be 4.5696 divided by 2.7, because LS base is 2.753, so that is 1.66 per unit, right. Similarly LAQ is equal to 4.432 divided by 2.753, that comes around 1.61 per unit, right. And we know LD is equal to LAD plus LL, right. Therefore it is 1.666 plus 1.66 plus 0.15 per unit. So it is LD is equal to 1.81 per unit, right. And LQ is equal to LAQ plus LL is equal to 1.61 plus 0.15. LQ is equal to 1.76 per unit, right. Therefore we know that LAFD is equal to LAFD upon LS base into IFD base upon IS base. All these things have been derived. So just we have to put these values. So the 40 upon 2.753 into IFD base 2158 divided by 18,881.5 is equal to 1.66 per unit, right. Similarly LFFD is equal to 576.92 divided by 316.12, that is 1.825, right. So directly you can, your what you call, just using those formula you can easily get all these things, right. Similarly LFD is equal to LFFD minus LAD, right, is equal to 1.825 minus 1.66. So LFD is coming around 0.165 per unit. Similarly your RA was given 0.0031 that is ohm, and divided by the base value, that is 1.03784, it comes 0.003 per unit. And similarly RFD is equal to 0.0715 divided by 119.18, that is 0.0006 per unit. So this is actually, this problem has been taken just to see that how to solve that your per unit transform the quantities to per unit values, right. So that's why this problem has been taken. Although what you can do is read the problem very carefully, and then all these data are there, just you step by step you follow that, determine all these things, and then you find out the base values, and then convert all these quantities to the per unit values, right. Just hold on. So just hold on. So now just hold on. So all these things, your what you call, for just 1 minute, just hold on, let me go back to a steady state analysis. From here we will start steady state analysis. Now so voltage, current and flux linkage relationship. Now we will come to the steady state analysis, and after that we will go to the dynamic analysis. little bit your study is required for steady state analysis, right. So voltage, current and flux linkage relationship, right. So the dq0 transformation applied to balance steady state armature phase current result in steady your direct currents, right. This is also true of the stator voltage and flux linkages. This we have seen, right. Since rotor quantities are also constant under steady state, all time derivative terms drop out of machine equation, because at steady state that any term attached with p, that is d by dt, that is dot, right, all these things will be dropped, right, because at steady state those terms are 0. So in addition zero sequence component are absent, and omega r is equal to omega s is equal to 1 per unit, because steady state that your what you call synchronous speed and your omega s is equal to omega r, right. So with p psi, that is your all these dot psi dot terms, right, set to 0 in equation 122, 123 and 124. In that case, if you do so, in that case all this your what you call this r1d I1d is equal to r1q I1q is equal to r2q I2q, all will become 0. This is equation 136. That means at steady state all the terms are dropped, right. So I mean that is dot term, that is p psi terms are dropped, right, that is psi dot, because steady state psi dot is 0. So therefore all armature currents are 0. This is to be expected, since under steady state the rotating magnetic fields due to the stator current is stationary with respect to the rotor, right. So as the armatures are closed circuits with no applied voltage, currents are induced in them only when the magnetic field due to the stator windings of the or the field winding is changing. Otherwise, if it is steady state, if it is not changing, that means those your d psi by dt term is 0, right. So that's why we have written this equation, this all these things becoming 0, right, and we are dropping psi dot term. So that means the per unit machine equation, that is from 118 to 132 under balanced steady state condition, it becomes like this, right. So it is your this side you should this is from equation 118 to 132. All this case the p psi terms you drop. If you drop and rewrite those equations, this should not be seen, this should not be seen. So ed will become minus omega r psi q minus raid. All these things are in per unit, right. So this is equation 137. Similarly, eq is equal to omega r psi d minus raiq. So this is actually equation 138, right. And similarly, efd is equal to rfd ifd. This is equation 139, and psi d is equal to your minus ld id in plus lad ifd. This is equation 140, right. Similarly, just one goes psi q is equal to, just let me move it up. Similarly, psi q is equal to minus lq iq. This is equation, this should not be seen, this should not be seen, right. Similarly, psi fd is equal to l ffd ifd minus lad id. This is equation 142. Similarly, psi 1d is equal to l f1d ifd minus lad id. This is equation 143. Similarly, psi 1q is equal to psi, because we have assumed that two armatures are there on the q axis. So psi 1q is equal to psi 2q is equal to minus laq iq. This is equation 144, right. So left this right hand side, this thing you should not see. So now field current from equation 140, I mean from this equation, from this side is equal to minus LDID plus LADIFD, from this equation, from equation 140, right. So you can write that IFD is equal to your psi d plus LDID upon LAD, that is equation 145. Now substituting for psi d in terms of EDIQ from equation 138, right. If you come to your 138, whatever 37, 38, EDIQ, whatever is given, if you substitute, you will get this expression of IFD, that is EQ plus RAIQ plus omega R LD ID divided by omega R LAD. This is equation 146, right. Thank you very much. We will be back again.